In the words of Carl Benjamin Boyer, mathematics is as much an aspect of culture as it is a collection of algorithms. Now, let us write a formula for area of a triangle when three vertices are given, and let us prove it. Area of a triangle with vertices x x1 y1 order pair x1 y1 x2 y2 and x3 y3. Here three vertices of a triangle are given. Area of, let us take these three vertices, let us take these three vertices as A x1 y1, B x2 y2 and C x3 y3. In this case, area of triangle ABC is equal to area of this triangle. Area of triangle is equal to half modulus x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 square brackets. Area of triangle is equal to half modulus x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 square brackets. Here modulus we keep modulus because area of a triangle is never negative. See, absolute modulus modulus symbol. The modulus symbol we call it as absolute value also. Absolute value. Absolute value of a real number is never negative. Absolute value of a real number is never negative. Here, modulus 2 value 2, modulus minus 2 value minus of minus 2, that means plus 2, modulus 0 is 0. We define absolute value, that means modulus of a real number. If x is a real number, mod x is equal to x if x is greater than 0. Mod x is equal to minus x if x is less than 0. Mod x is equal to modulus x is equal to 0 if x is equal to 0. Now let us prove the formula. Area of triangle is equal to half modulus x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 square units on coordinate axis. Now I am taking this triangle on coordinate axis. Horizontal reference line is called x-axis. Vertical reference line is called y-axis. Intersecting point of x-axis and y-axis is horizon O. I'm taking a triangle on this axis. For example, here the triangle A, B, C with ellipses A, x1, y1, B, x2, y2, adopted x2, y2. C is adopted x3, y3. We know adopted x1, y1, x coordinate is x1. x1 is nothing but distance from y-axis to a point. First of all, I draw perpendiculars from A, B, C to x-axis. Draw AL. Draw AL perpendicular to x-axis. BM. Perpendicular to x-axis, and CN perpendicular to x-axis. Next, we know clearly distance from x-axis to a point is called y-coordinate. That means BM is y. BM is equal to y. Very clear? BM is y. BM is y. Next, AL. AL is here you have length distance from x-axis to point is called y coordinate. That is y1. That is y1. So AL is y1. AL is y1. Next, distance from x-axis to a point is called y coordinate. So that CN is y3. CN is y3. Next, distance from y-axis to a point. Distance from y-axis to a point, perpendicular distance from y-axis to a point is called x-coordinate. That means it is x1. Suppose AP is x1. AP is x1. Next, perpendicular distance from a point to y coordinate is y-axis is x coordinate, that is x2, that is BQ. BQ is x2. Next, perpendicular distance from a point to y coordinate, y-axis is x coordinate. That is CR is x2. CR is x3. CR is x3. And it is very clear that OQBM is a rectangle. So the rectangle opposite sides are equal. Therefore, BQ is equal to OM. So that OM is equal to x2. OM is x2. OM is equal to x2. And then OPAL is also a rectangle. so that in rectangle opposite sides are equal, as AP is x1 units and OL also x1 units. x1 units. OM is x2. OL is x1 units. OL x1 units. Next, ORCN. It is also a rectangle. In rectangle, opposite sides are equal, so that CR is equal to OM. CR is equal to OM, so that ON length is here the distance from C to R, distance from y axis to a point is what? Exported, that is x3. So CR is x3, so the CR is equal to OM, that is x3. ON is x3. Now let us see, as OM is x2, OL is x1. It is very clear. ML is equal to OL minus OM. ML is equal to OL minus OM. That means ML is nothing but OL is x1, OM is x2. So that x1 minus x2. x1 minus x2. See, ML is x1 minus x2 units. In the same manner, ln is nothing but ln we can write as ln is ON minus ON. ln is ON minus ON. ON is x3 minus OL is x1. ln is x3 minus x1. x3 minus x1 is ln. x3 minus x1. That is ln. Next, here if we observe BMLA, it is a quadrilateral. ALNC is one quadrilateral. BMNC, it is also a quadrilateral. It is very clear. BMLA, these two are parallel lines. One pair of opposite sides are parallel in a quadrilateral. So that BMLA is a trapezium. BMLA is a trapezium. BMLA is a trapezium. Here AL parallel to CM, so that AL and C is also a trapezium. AL and C, one pair of opposite sides are parallel in this quadrilateral. AL and C is a trapezium. In the same manner, BM and C. Here, one pair of opposite sides are parallel, so that BM and C is also a what we call one pair of opposite sides are parallel, so that it is a trapezium. BM and C. BM and C is also a trapezium. Now, here we need area of this triangle. We need to find area of this triangle. Here it is the first trapezium, it is the second trapezium. If we take it as a third trapezium, If we add first trapezium area and second trapezium area, and then by subtracting the third trapezium area, we get area of this triangle. Area of triangle ABC is equal to area of the trapezium BMLA or ABML plus area of AL and C, trapezium AL and C, minus area of trapezium BM and C. If we cut BM and C trapezium area from this figure, if we cut BM and C area, trapezium area, we get area of this triangle. I am writing that. Area of triangle ABC is equal to area of triangle ABC is equal to area of trapezium BMLA plus area of trapezium ALC, area of trapezium ALC minus area of trapezium BMNC, area of trapezium BMNC, area of trapezium BMNC. We know area of a trapezium formula. Area of a trapezium, we know area of a trapezium formula. If lengths of the parallel sides A units and B units, distance between the parallel lines, perpendicular distance between the parallel lines is h. In the parallel sides, lengths of the parallel sides A units and B units, and perpendicular distance between parallel sides is h units, then area of trapezium formula area of trapezium is half h into a plus b, half h into a plus b squares. We can use this formula of h into a plus b square units to find the area of BMLA and ALNC trapezium and BMNC trapezium. Now, area of triangle ABC is equal to area of trapezium BMLA plus area of trapezium ALNC minus area of trapezium BMNC. Let us write that area of trapezium BML, area of trapezium BMLA. These two are parallel sides, and ML we can take as distance between those parallel sides. So, area of trapezium we know half h into a plus b. Here h is ML, A is BM, B is another side is AL. So, half h mean ML into A plus B. That means BM plus AL. Plus area of AL and C. These two are the parallel sides and distance between the perpendicular distance between them. That means height h, that is ln into half h, that is half ln into parallel sides AL plus CL, AL plus CL. Area of triangle BMNC, it is also trapezium, half h into a plus b, half h means BM, distance between the perpendicular distance between parallel sides, that is MN into parallel sides BM and CM, BM plus CM. Now we can talk of ML. ML is x1 minus x2 into BM. That is BM is y2 plus AL. AL is y1 plus ln. ln is x3 minus x1. x3 minus x1 into AL. AL is y1 plus CN. CN is y3 minus mn. mn here ON is x3, OM is x2, so that mn is x3 minus x2. mn is x3 minus x2, so x3 minus x2. x3 minus x2. Next, BM. That is BM is y2 plus CN. CN is y3. Let us simplify it. Half into x1 into y2, x1 y2, x1 into y1 plus x1 y1. Next, minus into plus minus x2 into y2, x2 y2, minus into plus minus x2 into y1, x2 y1. Next, x3 into y1, x3 y1, x3 into y3, x3 y3. Next, minus into plus minus x1 into y1, x1 y1, minus into plus minus x1 into y3, x1 y3. Next, plus into plus plus, plus into minus minus x3 into y2, x3 y2, plus into plus plus, plus into minus minus x3 into y3. Next, minus into plus minus into plus minus, minus into minus plus x2 into y2, minus into plus minus, minus into minus plus x2 y3. Close the bracket. Now let us simplify it. Half into, here very clear, here plus x1 y1 minus x1 y1 plus x1 y1 minus x1 y1, we can cancel. Next, minus x2 y2 plus x2 y2 minus x2 y2 plus x2 y2 can get cancelled. Plus x3 y3 and minus x3 y3 plus x3 y3 minus x3 y3 can cancel. Now let us write the remaining terms. Here this term x1 y1, here x1 y3. These two terms are writing together, x1 into y2 minus x1 y3. Next, x2 having terms, x2y minus x2 y1 and plus x2 y3 plus x2 y3 minus x2 y1. Write these together, plus x2 y3 minus x2 y1. Remaining terms, x3 y1, x3 y2 plus x3y1 plus x3y1 minus x3y2. Write these terms. Next, half into from these two, take these pairs. As we can common from these two x1, from these two x2, and from these two terms, we can common x3. Half into x1. If we common x1, here we find y2 minus y3. Plus from these two we can common x2, y3 minus y1. From these two we can common x3, so that y1 minus y2. So half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y1. In fact, area of a triangle is a real number which is never negative. Area of a triangle is never negative. So that we can write this expression in modulus, under modulus. Half modulus x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 squares. So area of a triangle when three vertices are given. So area of a triangle formula when three vertices say x1 y1 x2 y2 say x3 y3 are given is half modulus x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 square units. Generally we denote area of a triangle with delta. This is the formula for area of a triangle when three vertices are given.